Good day everyone. In this video, I'm about to show you how to perform AND gate, OR gate, and NOT gate all together in this breadboard using dip switches. So you might be intrigued why we have two dip switches which is an 8-pin dip switch and a 4-pin dip switch when we can only use an 8-pin dip switch in performing these three gates. So, what is dip switch? A dip switch is used like a switch button in controlling the currents or the electricity current flowing in this breadboard. So each pin or each switch here, this switch 1, 2, and so on, has its pair of pins. So the first pin is in here at the bottom and the second pin is here at the top. So to be functional, each pin should be present or visible. So to answer your question, take a look at the picture in our 8-pin dip switch. As you can see, switch 1 to 5 and 8 has a pin that is missing, so it cannot be used. But the 8-pin dip switch is still functional because it has switch 3, 4, 6, and 7 that can be used in knowing its purpose. So that is why we have backed up a 4-pin dip switch so that we can perform all those three gates. Now let's perform the AND gate. So in performing the AND gate, we will be using the integrated circuit 7408. Now first off, the most important wirings or connections is this one in pin 14 and in pin 7. So what are these two? In pin 14, it holds the VCC, which holds the positive energy that will flow here in our integrated circuit. And the other one is the ground. Opposite to VCC, ground holds the negative energy that will also flow into our integrated circuit. So, in the picture, that is the integrated circuit configuration of the AND gate or the 7408. So as you can see, it requires two inputs to come up with an output. In the picture, pin 1 and 2 is the input and its output would be in pin 3. Here in my model, pin 4 and 5 are my inputs and the output would be in pin 6. So that is why my wirings, its starting point is here in pin 4 and pin 5. Then its other end would be here in our dip switch connected. Pin 4 would be connected in switch 3 and pin 5 would be connected in switch 4. Now my output is in pin 6. So as you can see, my LED bulb is here in line with pin 6. So in this bulb, as you can see, the other end is longer than the other. So the longer one will hold the positive energy and the shorter one would be the negative. So I will put the shorter one here in our negative side while the positive would be in line with pin 6. There. So here, as you can see in our wirings, it has also a resistor in each input. So, as what I have discussed, resistor will limit the flow of energy to completely perform its purpose on the integrated circuit, or it completely perform what should be the output of your integrated circuit. So here, the first end of our resistor is in the first input, while the other resistor is on the second input. They both hold the negative charge for its input. Here on the other side, we have two wirings, which is also connected in switch 3 and switch 4. So they hold the positive energy that would be flowing here in our dip switch. So when we control the flow of the electricity, we will use the switches. So to know how to control the switches, we will see in our truth table for the AND gate. So as you can see, 0, the first input is 0, then the second input is 0, so the output would be 0 also, or no light. So next, if the first input is 0, then the second input is 1, still the output would be 0. Next, if the first input is on or 1, then the second input would be 0, so our output would still be 0. So if our both inputs turned on or positive, the output would also be positive or would turn on. Now, let's perform the NAT gate. So in performing the NAT gate, we will be using the integrated circuit 7404. So as you can see, same as the AND gate, we also have the VCC and the ground, because this is the two crucial parts that would be needed in performing the circuit. So in the picture, that is the IC configuration of NAT gate, or the 7404. So as you can see, it only requires one input to have its output. Here in my model, I've used pin 3 as my input, then pin 4 for my output. So pin 3 connects to the switch 6 in controlling the flow of our electricity. It also holds a resistor to limit the energy that would be flowing in our circuit. Then also on the other end, as you can see in switch 6, at top of it there is also a wiring that would hold the positive charge that would flow here in our dip switch. So now, let's perform the truth table of the NAT gate. It only has 2. So if the input is 0, our output would be 1, or it will turn on, or the flow of the current will be positive. Now, if our input is 1, our current is stopped, or it has a value of 0. So that is how you perform the NAT gate. So last is the OR gate. So in performing the OR gate, we will be using the integrated circuit 7432. So in the IC configuration of OR gate, it also requires two inputs to come up with an output. So same as the AND gate. So here we also have the VCC and the ground. Then I have used the inputs in pin 4 and 5, then the output in pin 6. So pin 4 and 5 is now connected to switch 2 and 3. Then our LED is now connected in pin 6. Now let's perform the truth table of the OR gate. So as you can see, if both inputs are 0 or in off state, the output would also be in off state or in a value of 0. So if input 1 is an on state, our input 2 is in off state, then the output would be in on state. Next, if our input 1 is in off state and input 2 is in on state, our output would be in on state. So now, if both inputs are in on state or in a value of 1, the output would also be in a value of 1. So that is how you perform the OR gate in the breadboard. And now, let's perform all three gates together in this breadboard. So the sequence would be AND gate, NOT gate, and OR gate. So in AND gate, as long as one of the inputs is 0, the output will always be in 0. Next is the NOT gate. So if we turn off the switch, our output would be on. And if we turn on the switch, our output would be in off state. And lastly, our OR gate. So in OR gate, as long as one of the inputs is in on state, the output will always be in on state. Now, turning on altogether the three gates in our breadboard. So as you can see, there is a change in the currency of the light or the light strength of each LEDs because all three LEDs share only one source or one power source. So they are dividing the 9 volts power source in those three LEDs. So that is how you perform all three gates all together in the breadboard. And that ends our video for today. I hope you learned something. Bye!